Introduction for turbidity. Turbidity of water is an optical property that causes light to be scattered and absorbed rather than be transmitted. The scattering of the light that passes through a liquid is primarily caused by the suspended solids. The higher the turbidity, the greater the amount of scattered light, because even the molecules in a very pure fluid scatter light to a certain degree, no solution will have zero turbidity.
The objective of turbidity tests are to determine the turbidity of the given water sample and to know how to use the turbidity meter.
Introduction of jar test. The required chemical dosage for particular raw water is virtually impossible to determine analytically because of the complex interrelationship that exists between this chemical and the constituent of the water being treated, as well as such factors as pH, temperature, and the intensity and saturation of mixing.
Jar test, the objective is to determine the optimum dose of coagulant for a specific water.
Six beakers which filled with 500 ml of water sample are placed under each stirring head. By using the measuring pipette, add the coagulant in increasing amount of 10 ml into each beaker. Start stirring rapidly in 60 to 80 rpm for 1 minute. Then the speed is reduced to 10 to 30 rpm for 15 minutes. After the stirring period is over, stop the stirrer and allow the float to settle for about 10 minutes. 10 ml of each clear sample is pipetted from each beaker. Now, let us proceed to turbidity test. First, allow a short warm-up period for about 5 minutes for the turbidity meters. Then, calibrate the turbidity meter using the standard tubulation suspension. A sample tube is prepared and wiped using a clean cloth. Then, pour the sample into the sample tube. Be careful not introduce any air bubbles into the sample tube. Lastly, the turbidity is read and recorded. These are our experiment data and results. So based on the current dosage in the turbidity value gain, we have to plot the graph of turbidity with the current dosage. Based on the plotted graph, the optimal current dosage is 18.5 mg per L. Turbidity of the optimal current dosage is 2.7 NTU. There are several factors affect the accuracy of the result, which are the sample tube is not filled with distilled water, the sample tube inside got the air bubbles, and the temperature of the water sample is not uniform. The time taken for the float to settle is insufficient. So, in order to overcome this, the time taken for the float to settle is about 10 minutes, and we have to avoid any periodic error, and the temperature of the water sample must be uniform.
Questions. What is coagulation? List down 3 examples of coagulant. Coagulation is a process that involves a neutralizing charge on the particles. The purpose of coagulation is to destabilize particles through chemical reaction between coagulant and colloids. Example of coagulant: alum, ferric chloride, ferric sulfate. Next, give the importance of jar test. To determine the optimum coagulant dosage, to determine the optimum pH so that it can be carried out in the most suitable pH adjustment, to determine the quality of coagulant used.
As a conclusion, for the experiment, we noticed that before the current is entered inside the water sample, there is no visible float forms. So after the current entered inside the water sample, we can see that the white float is formed. So after the jar test, we carry out the turbidity test. So for the whole test, we get the optimum current dosage is 18.5, and the turbidity of the optimum current dosage is 2.7, which is the lowest turbidity also. So thus, both experiment objectives are achieved.